Hi everyone, welcome to my YouTube channel. I have created a new series called Networking Basics and today's topic is Vlan. So let's get started. Why do we need a Vlan? Vlan stands for Virtual Local Area Network. So in order to understand why do we need a Vlan, let me take you to a story. So let's say I do have a switch which has like 48 ports in it. Out of this 48 ports, let's say I have connected 40 end devices. It can be a PC, it can be a laptop, right? I have connected it. And out of this 40 devices, 10 device belongs to department A, 10 belongs to department B, 10 belongs to department C, and so on. So now, let's say device A is trying to reach out to a device B. When it first sends the packet to a switch, once a packet reaches the switch basically does something called ARP to understand who has this MAC address, destination MAC address. So basically an ARP request is sent to all the ports and the device which owns that MAC address responds to that ARP message. So all the 48 ports will be receiving an ARP request. And let's say if I connect another switch to the first switch and another switch has another 48 port, in that case a single ARP request will hit 47 plus another 48 ports. So these broadcasts, so the whole point is a switch will have a single broadcast domain, right? Which means if a broadcast is sent, all the ports associated to that switch, right, will be receiving the broadcast. So that's the problem that we are trying to solve, right? With VLAN, we can reduce the broadcast domain, right? So that's one of the key advantage of using VLAN. Apart from that, this virtual local area network will help in increasing the security, right? I'll come to that point how it adds the layer of security. And since the broadcast packets are reduced, right, the performance will be increased, which means the bandwidth will be increased and the latency will be reduced. So that's the advantage of using VLAN. There are two types of VLAN. VLAN can be based out of a port or based out of the source MAC address. So most of the practical examples or practical real life scenarios will be based out of port based VLANs. And then one of the key characteristics of VLAN is basically, let's say if I have a device and it is connected or it is tagged to a specific VLAN, and I have another device which is tagged to another VLAN, those two devices will not be able to speak to each other even though they are part of the same switch or same network. So that's the VLAN characteristics. So let's take a look into .1q headers. The first frame which you are seeing is a normal Ethernet frame. It has a preamble, it has a destination MAC, it has a source MAC, it has ether type, it has a payload and CRC. So when we introduce VLAN, right, that to especially 8.2.1q or .1q encapsulation, a header is actually introduced between source MAC and the ether type. So this header is 32-bit header, and when you look closely into that 8.2.1q header, it has 32 bits, out of which 16 bits belongs to TPID, 3 bits belongs to priority, 1 bit belongs to DEI, and 12 bits belongs to VID. So this 16-bit is what we call it as tag protocol identifier, and this 16-bit is always set to 0x8100. So this is set to this value in order for the frame to be identified as .1q tagged frame. And we do have rest of 16 bits. Out of 16 bits, we have 12 bits assigned to VID. VID is VLAN identifier. So 2 to the power 12 is 4096. So basically, you can assign VLAN starting from 0, maximum of 4096, and there are few reserved VLANs which you will not be able to use. So we do have a limitation in number. So the maximum VLAN that you can have is 4096. and we do have priority code point. So this field, right, this PCP can be you can set a value from 0 to 9, and different PCP values can be used to prioritize different class of traffic. And one bit which we call it as DEI, drop eligible indicator, and this is basically used to to make sure that the frames eligible to be dropped, right? So when this bit is enabled, that makes that these frames can be dropped in the presence of congestion. So this is how the .1q format looks like, header looks like, and where this header sits in the actual Ethernet frame, and this is how it looks like, right? One other key point which I just wanted to highlight is when you tag a frame with a VLAN, right? That packet cannot be sent to another port which is tagged with a different VLAN, right? So that's the key characteristics of VLAN. So let's say if a packet is sent from a device which is tagged with a VLAN 10, and let's say there is another device which will be tagged with VLAN 20, by default these two VLANs will not be able to communicate with each other, even though those two devices might be belong to a same network, or they will be connected to the same switch, even though they will not be able to speak to each other, right? So in my next video, I'm gonna have a practical session with Cisco Packet Tracer, and I'm gonna go over different methods of inter VLAN routing, right? So I will see you guys there. It's going to be an interesting session where I will be speaking about how to achieve inter VLAN routing, and what are the different methods that is available to in order for you to achieve the scenario. Yeah, thank you.